些 setup。那请大家先稍作休息一下。那我们下一个的座谈呢，叫做以太坊2.0冲出宁静号。Our panel discussion will start in 1 minute. 那我们现在座谈会呢将会在1分钟之后开始。那这个座谈呢最主要会以英文为主。The panel will be carried out in English. Okay. 那我们现在就把主持棒交给小薇。
Hello everyone. Good afternoon. Hi. So this is Xiaowei. And I'm the moderator today. And today we will have eth2.0 discussion. So we will talk about the history, the future, and our experience with this eth2 experts. So okay. So maybe introduce what's your name, and what's the organization you're working on, and what we have been busy with recently.
Hi. Yes, sir. Hello. Hi, I'm Adrian. I work for Sigma Prime, which is a company that is building an Ethereum 2 client in Rust. Okay, I'll start again. My name is Adrian. I'm a co-founder co-founder of Sigma Prime, which is a company that is, among other things, it's a security-based company, but among other things, it's building an Ethereum 2 client in Rust called Lighthouse. I'm one of its developers.
I'm Vitalik. I'm a developer for Bitcoin Tools, co-founder of Bitcoin Magazine. Recently I've been doing some Ethereum stuff.
Hey, I'm Danny. I work on things with these people. We work on Ethereum 2 research, specification, and client coordination and development.
Hey everyone, I'm Alex, focused on eth2, right now the Serenity client, which is in Python, which I'm sure we'll get into why that's a ton of fun.
Hi everyone, I'm Diederik. So I maintain the Go specification. We try to make the spec executable so you can provide this test tooling infrastructure for these different clients.
Yeah, thanks everyone for joining the panel. And so we know that eth2, it contains so many new features. We will have proof of stake, we will have scalability with sharding, and what else the core value that you feel you want to highlight for the audience?
I'm not going first.
Core values of Ethereum 2. In my opinion, one of the core principles is Ethereum 2 is it's an upgrade. It's an upgradability. We're choosing some of the latest tooling, some of the latest protocols, some of the latest core technologies. A lot of it's currently being developed, actively being developed, and we're trying to build it into a new blockchain. So, which is why we can't build it on Ethereum 1. That's why it's a new chain, because we're replacing everything.
Yeah, I'd say the core value is we've learned a lot since Ethereum launched, and it's time to take all those learnings and make a better, more upgraded system. But at the same time to recognize and celebrate the community of developers and users that is built around Ethereum, and to ensure that we do our best to kind of capture that community and move forward into Ethereum 2 and make that process as easy as possible.
Yeah, people have been liking the word seamless in terms of a seamless ETH1 to ETH2 transition. There's a lot of conversation last week at DEF CON and probably over this weekend about that type of stuff.
So personally I think it's really good that Ethereum 2 does not opinionate the core layer so much, and that the community can build these other great things in forms of like EEs and other tooling closer to the core layer. So there's a lot of things that can emerge on Ethereum 2 that are not possible on Ethereum 1.
Yeah, so I guess going back a bit to the original values of Ethereum 1, I guess first of all, we love decentralized applications and open platforms and all of the wonderful things that you can build on top of that. And the goal of Ethereum all along has been to create a general purpose platform where people can essentially just feel free to go and build things, and where you can build decentralized applications, whether it's finance or some identity thing or whatever you want to build, and you can just write a piece of code and upload it, and you don't really have to think about who's going to run your consensus, or how are you going to talk to these other applications or accounts or any of those other details, because the Ethereum platform kind of takes care of all of the common stuff for you. And I see Ethereum 2 as kind of being a logical extension of that vision, and it's trying to preserve it as much as possible, but at the same time deliver kind of massive upgrades in scalability and efficiency, improve security through the proof of stake, and make the platform even more general purpose with things like execution environments and account abstraction, and just generally, as Danny said, take all the things we've learned from the last few years and make the best platform that we can.
And yeah, so before we move forward to the eth2, let's move back, recall the history. So the reason why I think eth2 is difficult is that we have to fight with the backward compatibility than other new blockchains. And there's a deprecated sharding contract and also the deprecated Casper contract, the EIP 1011. So could you introduce why this change happened and what's the difference between the old Casper and the new Casper and the current beacon chain Casper?
Ooh, I remember that contract. I think I wrote it. Yeah, in Viper. Yeah, I guess the big change that we did about 1.5 years ago is that we decided that instead of building eth2 as this kind of layer 2 that's rooted in the existing eth1 chain, and then in parallel trying to upgrade eth1 to Casper, we would create a new system. And the benefits of the new system is basically that we would be able to dual optimize it for the specific challenges and use cases of sharding much more easily. So we would not have to worry about like, oh, can we verify BLS 12381 inside of an EVM, or like what's the gas cost of updating state? Like we can kind of feel free to kind of design data structures and a lot of other things in ways that make it that make eth2 much more efficient, and also just like instead of having this one kind of train of work that is doing eth2 or that is doing Casper and this other kind of separate train of work that is doing sharding and kind of eventually hope to merge them, we kind of build a newer system from the beginning and then kind of link it to the existing system, and so the new system can run by itself for a bit and then eventually kind of move more and more activity to it over time.
Yeah, one of the other reasons that it was made a lot of sense to switch was that the two paths that we were taking that had a lot of execution happening within the EVM were going to ultimately limit the amount of consensus participants, the amount of validators that could participate in the system, and thus you had like high capital lockup costs per validator to participate. We were worried about just ultimately the decentralization of such a system. Taking this more radical approach by re-architecting the system in parallel has allowed us to greatly lower the minimum requirements to participate to on the order of 32 ETH. And so I think we can have a lot more participants and a lot more decentralization from that.
Thank you. And so, okay, let's talk about beacon chain. So the beacon chain development, it's a huge project right now. It includes like, I think 8 active clients, right? Including Lighthouse, Adrian, and also Alex and I are working on the Trinity Python client. So what are the common misconceptions that people, our audience may have for the beacon chain, I think, in your opinion?
I think part of it may be just understanding the relation of the beacon chain to ETH1. So like it is a separate chain. It's actually done this way so we don't couple the systems, until you have to. It could be the case that there's only a one-way bridge from ETH1 to ETH2, and then if there's something terrible that happens on ETH2, we can like correct it there and not have to really worry about the ETH1 consensus. So it's really just like risk minimization.
Okay, I'll just add to that as well that in phase 0 there's no data or execution environments happening in any of the shards. So when we release phase 0 on mainnet, that doesn't mean you can start running contracts and applications yet, but soon.
Yes, but soon.
Soon.
Soon, TM.
Okay, then so like next year we will have beacon chain, and then phase 1 is coming. So I did a asset on Nimbus, and we did a developer survey last month. So we figured out that, so Talik introduced the front proof, the data availability yesterday, but I think it's only like half of our community, they really aware of the phase one is only for data. Does anyone want to elaborate it more about phase one?
Yeah, and the goal has basically been to all along launch Ethereum in phases so that we have an opportunity to kind of test each component under kind of real conditions for some time before releasing the next one, and particularly have the system tested, or as much of the system as possible tested for as long as possible when people start putting a lot of economic value on top of it. And so the three kind of natural separations to have is basically one, proof of stake, the second, sharding just for data, and the third being kind of sharding and including data and computation. And the reason to make the distinction is because there are things in phase two with computation that are there are phase two specific problems. Like once you have phase one, adding phase two is not completely trivial. So we have to, for example, kind of fully spec out the design for how Ether moves across shards, for like exactly what kind of execution it is, for get the clients what all needs to implement WebAssembly, like what they want to optimize WebAssembly, a lot of different details. And like, there's no point, I guess, in kind of delaying release of the entire system until the entire system is ready, when you can kind of get parts out earlier and get them running earlier and get people doing some things with them. So for example, like when you have phase one, then the chain won't do computation, but the chain will be able to hold a lot of data. And so if, for example, we come up with a way where the ETH1 chain can be aware of the ETH2 chain, whether it's through like a built-in bridge, as Danny was talking about yesterday, or through a light client, then you could have optimistic rollups start using phase two and go up to like hundreds of thousands of transactions a second just as a rollup, like even before all of the other applications start running. So you kind of crank up the complexity over time, crank up the utility over time, and it's a kind of naturally safe and progressive approach.
It's also allowed us to parallelize different portions of the development. At first, when we were researching, speccing, and people were trying to build phase zero all at once, it was kind of like we'd be bottlenecked, like different parts of the process would bottleneck different other parts. But now that phase zero is relatively stable, engineering is like very actively working on that. At the same time, the research team is specifying phase one, and at the same time, like super active research between the research team, WASM team, Quilt team, and some others are actively researching the things that are going to go into phase two and the specifications that come. So now, by like having things very cleanly separated into phases, not only for logical like building, but for kind of like release, we have like a lot of things moving all together, which is definitely a benefit.
Cool, thank you. And so speaking of this, I think we actually have like 3 different groups. Sorry, the client teams are working on the phase 0, the implementation, and the protocol designer are working on the phase 1 refining, and also there are the phase 2 teams like CRUD and EWASM, they're working on the phase 2. EEs, the execution environments implementation, and POCs. And people are worried about that. So we have the EEs and POCs right now, and people are worried about the composability between ETH1 and ETH2. And they were worried about like, can we still use like ERC20 in the new system, and how's the cross-track translation change that, and Would you like to elaborate it?
Yeah. So people at DevCon definitely, talking to developers, are concerned about composability in a sharded system, just in general. If you have state applications that exist in certain shards that want to speak, communicate, and interact with applications on other shards, that fundamentally looks different than it does at layer 1 today in Ethereum, where I can make a call from contract A to contract B within the same transaction, have the results affect one or the other. And so generally in a sharded system, you don't break composability. Applications can similarly communicate with each other in an asynchronous manner rather than a synchronous manner. The problem is that you do have certain things change in the developer experience around certain things like guaranteed atomicity of actions and having things happen within the scope of just a single transaction. And so the developer experience around building applications in a sharded system might very well change. But if we have sufficient tools in the higher level languages to deal with and mask the complexity, you can ultimately compose applications in a very similar way and do similar things that we're seeing on eth1 and likely do even more. So definitely a concern and definitely something that we want to spend sufficient time in language design and toolings in languages to deal with, but not something that it doesn't break composability as people were saying.
Yeah, and so like the main change that you get when you shard is that like things within the same shard don't work just as they worked before, and communication between shards can still happen. And like with the new phase 1 proposal, it can even happen within one slot. But communication between shards is asynchronous instead of being synchronous. So what that means is that like you can do a thing on shard A and have an effect on shard B at one slot later. But what you can't do is do a thing on shard A, cause it to read something on shard B, and then based on the reading from shard B, immediately do something else on shard A right after. Like you can implement these kinds of things on top of locking schemes, but like you can't do it directly, right? And so what that means is that like first of all, things like ERC20s, for example, like you need to redesign them a little bit because, for example, you can't have like one contract on one shard, the token contract. You would basically have to have your token have some kind of presence on every shard, and like that's fine. Like even the duplication of the code is not a big issue because if you just put the code on the beacon chain as a beacon chain contract. And like if you want to do these applications that say, oh, I want to do one thing, and then based on that one thing, I do another thing, based on that thing, I do a third thing, like there is also this kind of yanking mechanism where you take kind of individual contracts and you first pull them all into the same shard, then you do a synchronous thing, and then if you want, you can move them out. And this is kind of a generalization of locking as it exists in traditional kind of database atomic transaction theory. And you would need to use different design patterns that kind of maximally take advantage of locking. So for example, the more you can kind of design your application as being a set of different contracts with one contract per unit of activity, the better. And a lot of things do work that way, right? So for example, ENS names are independent contracts, MakerDAO CDPs are independent contracts. Like you would just need more things to have that workflow, and then you would be able to have that kind of synchronous, like do 10 things at the same time ability as you do now. So you'd have to think a little harder, but it's still there. And if you don't want to think harder, you can just live on the same shard as the stuff you want to interact with.
Thank you for the elaboration. And another thing that worries the community is that about the eth1 to eth2 transition, and also how to use eth2 as the finality gadget for eth1 chain. Okay, and I know that Alex is working on the working group about this topic. Would you like to share some information of it?
Yeah, well, so hopefully you've gotten the idea that what we're doing is like quite ambitious, right, with all of eth2. So, as Vitalik and Danny have been saying, like there are tangible benefits we can get out of each phase as it goes. So one of these would be using the beacon chain, which is this first phase, launching soon TM, to finalize the eth1 chain. So this is the finality gadget. A lot of these more interesting two-way bridge concepts or data availability sort of applications we want to do on eth1 would require the eth1 chain to know about the eth2 state. So this would essentially be the way to do it. So we've started the very beginnings of a working group to look into this stuff, as Shelly mentioned. But we're literally at the point where it's okay, we'll start an initial feasibility study. Does it make sense to do this? Danny went into this yesterday in his talk, but essentially it's very risky coupling systems. So if we can avoid it, that's perhaps almost preferable. So then the question is okay, how fast can we get eth2 out? How quickly can we change eth1? And you kind of have all these concerns racing.
Yes, and also Danny talked about eth1 to eth2 bridge yesterday, which and also Vitalik will second Danny's conclusion yesterday, which is seeking a balanced design and roadmap in a world of trade-offs. For and says the conclusion, a good conclusion for all the protocol developers. And so as you are the first developer of Ethereum, can I say that like that? Okay. And from the white paper eth1, eth2, and is there any remarkable trade-offs and the decision that you committee made and that you'd like to share about trade-offs?
Trade-offs. Maybe the DAO fork. That was a big trade-off. I guess there were lots of trade-offs in Ethereum. And one of the kind of complexity versus functionality was a big one. So for example, the Ethereum chain added a lot of functionality, and we have the state tree, we've added receipts, we added different kinds of cross-contract calls. At some point, we decided that enough was enough, there were features that we wanted to do that we ended up just not doing because there wasn't time. One of them, for example, was scheduled calling. So make a call now that is guaranteed to execute, say, 10 blocks or 100 blocks from now. And retrospectively, I think it was a very good idea that we abandoned that because otherwise we would have realized that there's these really serious economic challenges in making it work. For example, what if during every block between, say, block 1001 and 2000, everyone schedules a call for block 2001, and then block 2001 takes 5 minutes to process, right? That's a problem that we did not even realize existed, but we just decided, even before realizing it, that it wouldn't take too much time for too little value to provide scheduled calls, and thankfully we did not run into this problem. So that's one example of functionality versus complexity. There's obviously kind of performance versus security, and that's a trade-off that gets kind of litigated every day by miners as they upvote and downvote the gas limit. And by the community as they kind of yell on Reddit to tell the miners how to upvote and downvote the gas limit. I don't know, and there's a lot of kind of really subtle decisions involved.
Yeah, one that I mentioned yesterday was the going towards this new sharding proposal that has much fewer shards, but has a better user experience. And so total capacity of the system versus the UX of using that capacity. And so we're kind of constantly having these conversations around all of the trade-offs. We're discussing in the new sharding proposal whether it's worth having multiple shard blocks per beacon slot, which might enhance the user experience of having intra-shard transactions at the cost of some amount of consensus complexity. It's always a balance.
Another one would be the presence of EEs in phase 2, right? So we can kind of hold some elements of the full protocol abstract by just basically not doing them yet. This lets us experiment with different alternatives. We have more time to like explore these different alternatives and see what makes sense and what doesn't. It kind of opens a path down the road for this almost like permissionless exploration, right? So you could have different EEs on top of eth2. But then at the same time, this is now like really confusing perhaps to like people who haven't heard about it, or then it's like unclear like, well, I want eth1 but scalable, what is this EE stuff? Should I write a smart contract, write an EE? Wait, there's beacon chain smart contracts, so okay, wait, what? So part of that's like managing the complexity there and like how it's messaged to the community at large.
Mm-hmm. And constantly incorporating new information into our like view of that complexity. As we are just exploring the EE landscape and like the implications to developers and the complexity of building them or processing them and things like that, I'm kind of constantly wavering on like, okay, is this a good idea? Is this a bad idea? It's like,
what's EE?
So I mentioned a little bit in my talk yesterday. An EE is an execution environment. In eth1, we have hard-coded rules about account and state and what a transaction is and the structure of those things. Whereas in eth2, we're exploring this concept of abstracting those things such that they can be specified dynamically into the protocol instead of them existing hard-coded. That looks like essentially deploying some WASM code to the beacon chain that specifies how to interpret shard block data, essentially how to interpret transactions and how to store these things against a state root or 32-byte accumulator. It ends up, you can do the same thing, so you can make an EE that does what looks like Ethereum, but you could also make an EE that looks like Bitcoin or looks like some things that we haven't thought about. And this, as I mentioned yesterday, is a very appealing one because eth1 could be slotted in as an EE, while we can still experiment with all the new things and fancy things that we want to do in eth2 and maybe in eth2 EE. And it also potentially future-proofs the protocol in that we can create this like very scalable and decentralized layer that isn't necessarily opinionated about what you might do with it in say 20 years. So very exciting stuff, but also like new stuff that introduces new things that we have to think about and complexities.
Thank you. So let's move a little bit to move to the client discussion. So Adrian's here, and I know that Sigma Prime, the Lighthouse clients, they were very focused on building a secure client for the community, and there's also some further for the cross-client, for testing our cross-client, because there's like 7 clients here. Could you introduce it?
Yeah, sure. So my company is kind of focused on cybersecurity, so the client we're building has a strong focus in performance and security. So in our development cycle, the company consists of a number of security professionals, so in our development cycle we try and integrate security into it. One tool that we use, which has become relatively popular, is fuzzing, as you mentioned. Fuzzing is a security analysis tool which, given an arbitrary function that you have that has a number of inputs, you have this tool that just generates a whole heap of random inputs and tries to break the function. So typically when you're a developer and you're building some function, you have a set of inputs in mind, and so by generating a whole heap of random inputs, then you can typically find things that you don't otherwise expect when you're building these functions, and find parts where your client breaks. So we've been doing that in Lighthouse and more generally across all the Ethereum 2 clients. We realize that security is quite an important topic. So in in Ethereum 1 with the Shanghai DOS attacks, that there can be attackers that kind of can break different individual clients. So we don't want to just secure one client, we want to try and secure all of them. So in that effort, there's a global, I guess there's an open source contribution where we're trying to build a thing called a differential fuzzer, which is a fuzzer that plugs in all the clients at once and tries to spam it with all of these inputs, so that if any of the clients give different outputs on some very specific functions, we hope to catch any kind of discrepancies and fix those in the client so that it happens. We find those before we reach mainnets, fundamentally. So yeah, we're contributing to that collaboration.
Yeah, so the common testing suite and also fuzzer is very important for the cross-client implementation. And also, like I know that during the interop in September, that so many consensus failures were found across the client when the client actually connect to each other. And what's the biggest challenge you think for the client implementation so far, in your opinion?
Okay, two things on that. Yeah, so we saw a result of all of our differential fuzzing. So in the client, as you were saying, in the client interoperability tests, everyone had some malformed, had their own kind of encoding, and so when clients were trying to connect to each other, things exploded because you were getting inputs that you weren't otherwise expecting. So with Lighthouse in particular, we managed to avoid those kinds of issues because we had done this kind of testing. And just to answer your second one, the difficulty so far in building a client, I would say, is that the technology we're using is all fundamentally bleeding edge. We're building the latest everything. We've changed the signature schemes. We're using like the networking. We're using libp2p, as you saw it from Raul earlier, which is currently in development. There's a whole heap of things going on there. We're building the discovery alone is also currently being spec'd out. The client we're using is Rust, so even the language that we're building the client in is actively being developed. So it's hard to kind of keep track of everything as it's constantly upgrading. We've got to maintain it, and even if the language you're doing it is changing as well, it's quite a difficult task. But yeah, there's an update in Rust actually coming in a month that makes us have to rewrite a good chunk of our code, which is going to be interesting.
At least you have a compiler team, though. There's another client that they're even writing their whole language from basically scratch.
Yeah. Kudos to Status, the Nimbus team.
Yeah, so on client development, difficulties. Yeah, interop was fun, right? We all are using libp2p, which also is like sort of, it's awesome cutting-edge software. So we worked a lot with Raul and the Protocol Labs teams on like, how can we, kind of make this work for both parties, which I think has been really valuable. So there's a lot of stuff at the interop event where, yeah, for the first time, clients were talking to each other, and we found a lot of bugs just from that. On top of that, in particular, I mentioned I work on the Python client, right? So Python's great, it's like nice and readable. Compared to, say, Rust, it's generally much slower. So the question is like, okay, how can we make a really performant Python client? And there's a lot of challenges there just to even do that. That's beyond implementing the spec, beyond writing performance tests, and these sorts of things. So yeah, lots of fun.
Yeah, so I would like to add here, there's many clients, and we're talking about fuzzing, like just randomly finding a bug is already difficult enough. Imagine having like 8 different implementations, each with their own nuances, and so we shouldn't wave away testing. Infrastructure is really changing here, and so I hope like moving towards phase 0 launch, we keep this collaboration strong and help each other find bugs in like these different clients.
Thank you. Okay, and I have a question for Dedrick, especially. So, Dedrick is only 21 years old, and being an Ethereum researcher is his first job after school. So, you dropped. Okay, and I wonder that what's your story of that you found interest in Ethereum, especially Ethereum 2.0,
Right. So there's many different things to it. I can go into like history, all these different meetups I attended, or like what first got me into Ethereum. I'd just like to maybe summarize it. There's like, regardless of what your background is, maybe you should just focus on like what Ethereum offers. And so what I like so much about Ethereum is, well, I already mentioned the community. There's endless heaps of meetups all around the world you could go to, attend, learn about different things. You have to filter out some shitting maybe, like there are ICOs out there are projects out there. There are some good things. There are huge ambitions out there. And then besides community, there's this world of open finance. So you create everything that we'd like to see from our open world games we play. You have this power to create your own little economy, create your own rules, create your own systems. And then from there, it's like really this permissionless Lego, right? So think of DeFi Legos. You can build anything with these kind of like permissionless blocks, and they can come from everywhere. So anywhere really. So in the world, there's many different developer communities, and they all contribute back. All these different things, they come together, they emerge, and it's like the last really thing that got me into Ethereum is where we are building the Legos, where we're building the protocol, and where you can build these new like constructions. And then purely also the challenges. I like to compare it again to crypto puzzles. You have these capture the flag events online, where they pose like this computer science problem. You have to communicate with others, you have to show creativity. And then there's just this really challenging niche problem you can dive into for weeks and really try and dig in. And then it's really rewarding when you get out and come with a solution. And this really like all comes together to protocol development. And that's what we're doing here. I love it.
Thank you, Proto. And yeah.
Can I mention something?
Yeah.
Just the best hires that I think the EF has, and the best hires that a lot of the ecosystem has. Just to highlight some of the discussion yesterday and kind of how we found Proto, is just people that show up and do the hard work because they love it. And so like finding projects online and finding things that you're really passionate about, and again, the community is such that like you recognize, like there's only so many people in the world that like show up and just build random things on the internet and contribute. And so like it's so, your ability to like meet people and your ability to like integrate into these ecosystems and these companies and these systems is massive. And I was talking to Chang and some other people from the Taipei community, and how that's kind of like counter to some of maybe how Asian cultures operate, and just like show up and just say hello and just like operate in this like very direct way. But just go for it. And you know, again, Proto like he's one of the best contributors to the ecosystem, and he's just a guy that showed up and saw interesting things and started doing it.
Yes, and also I think we met at the East Global Hackathon for the very first time. So yeah, I joined the hackathon and in your
another little part of the story where after these many different meetups, a few conferences, I moved to Hong Kong as an exchange student, and even there again there's another community, more meetups, and then there was this conference, and I just missed Charlie by like 30 minutes. Like we could have been talking about Charlie maybe like, I don't know, like half a year earlier. It would have been fun. But like nonetheless, if you reach out and contact these people and show your interest, you're really welcome and you can contribute.
Yeah, just to add to that, I'm pretty sure all the Ethereum 2 client teams are looking for contributors. So if you just go into their repository, I know that we definitely are. So if you like Rust, or if you like Go, or if you like JavaScript, just go find their repositories, look at their issues. Sometimes they have good first issues to help you get started, and I'm pretty sure they're all very friendly.
Thank you. And I think we only have 2 minutes left. So the final question. what is the one piece of practical advice for you to give to the developer? Think if they are interested in different ways, and what can they look for? And the second question is, what can we looking forward to? So this the topic of this discussion is the next step to Serenity. So what can we look forward next, generally?
I'll have a crack at the first one. So, advice for developers, I think is the first question. In my opinion, if you find something that you're interested in, whether it's just a hard problem or just a particular language, just anything that you're passionate in, just dig really deep into that particular thing. You don't have to. So in my particular client, we're doing it in Rust, and we find some of the best people to work with are people that are really passionate about the Rust language. They don't know anything about blockchain. They don't need to know anything about blockchain, but they really, really, really like Rust. And that's perfect for us because we're writing things in Rust. So if you find something you're passionate about, just if it's anywhere in our space, just come and reach out. Even if it's some very, very niche part of Ethereum too. So in our client, we're doing a whole heap of things, which I tried to highlight. If you like DHTs, for example, something to throw back to Raul. You like DHTs and you want to build a new DHT, come and talk to us. Be passionate is my suggestion.
I have a quick question. How many of you are developers? How many of you that are developers have contributed to an open source project? Okay, about half or so. I spent a long time as a developer using open source, admiring open source, but not ever making a contribution. And so I will say, feel free to start small. Like if there's a typo in a README, just go fix it. Like if there's a tiny little bug on something, like some input parameter or something, and there's like a wrong balance check, just go fix it. Just go fix it. Just do it. And I found, like, finally, when I finally dipped my toes into open source, and I started just doing little things, like I got obsessed. Like I couldn't stop. And so not only if you love DHTs, go build a DHT, but like if you just like to code and you use open source, like just start making little contributions. Like they build up, and that's what open source is.
I definitely did some typo fixing back in the day.
And next up for eth2, testnets and phase 0 mainnet.
Does anyone want to add anything? Oh. Okay, thank you everyone.
那么再次感谢刚刚参与的所有的贵宾。那接下来呢，我们会有一个 tea break 的时间，那我们有25分钟。那我们下一场呢会是在2点45分回到现场。We're going to take a tea break right now, and our next session will start at 3:45.